Hi guys, here's an energy problem. It says find the final speed of a sphere having mass m and radius r that is rolling down a ramp of height h, inclined at an angle theta above the horizontal. So I'm told that my ramp has height h, and I'm looking for, we're going to assume that the sphere starts from rest. So when the sphere gets here and is moving with some speed vf, I would like to know what that value is. So if I write out my energy equation, so recall initial energy equals final energy here. We have mgh plus, let me back up for a moment, and write it out a little bit more explicitly. So the types of energy present in the problem are gravitational potential energy, kinetic energy of translation, and kinetic energy of rotation. So initially, I have the option of having all three of these energies present. I may not. And then at the end, same thing. Now, that being said, at the beginning, there is no translational speed, and the object is not rolling. So both kinetic energy of translation and rotation are zero. At the end of the problem, when the ball is at the bottom of the ramp, the gravitational potential energy is zero, and I'm left with a translational speed and a rotational speed. Now, filling in what I know, gravitational potential energy is mgh. Translational kinetic energy is 1/2 mv squared. And rotational kinetic energy is 1/2 I omega squared. Now, we're told in the problem that a sphere is rolling down the ramp, and if you will recall, the sphere has a moment of inertia of 2/5 mr squared. Taking that into account and also recognizing that omega can be written as v over r, let's see what we come up with. So we have mgh equals 1/2 mv squared plus 1/2 times 2/5 mr squared times v squared over r squared. Simplifying some things, if we notice, guys, the 2's cancel here, the r squareds cancel here, so I'm left with mgh equals 1/2 mv squared plus 1/5 mv squared gives us mgh equals 7/10. mv squared mass is going to drop out, so speed is the square root of 10/7 gh. I hope this is helpful, guys. Have a great day. Thanks.